Hey there, welcome back to the channel. Today we're going to continue our series on this robotic vehicle. Today we're going to do wiring of the motors, the controller, the receiver, and also these encoders inside the motor. Let's get to it. I don't know a whole ton about RC stuff. I've played with RC cars, but never really built one. One thing I do know, though, is when they lose signal or something goes wrong, they tend to just drive by themselves. While I'm wiring this up, I'm pretty sure I'm going to make some mistakes, and I don't want this thing taking off on the bench. So we're going to build something that we can put underneath here that will hold this in the air so that if it tries to drive, the tracks will just spin in the air. Easiest way is to just 3D print something that goes underneath all four corners, maybe connects together on each end so that it's easier to align. So let's just design and print a couple of those. Well, those look like they came out fine. Except they're too damn wide. Let's see if these ones fit any better. Well, it fits between the tracks, that's good. To make things easier to work on, I'm not going to bolt things right down to this chassis. Instead, I'm going to use something like this that can then be bolted down, maybe on some standoffs, whatever. Then I'll take the controller here, so this is the drive controller. Need to make sure I can get to this USB port for programming, and then it's easy to reach all of these connectors, things like that. Looks like it's got a big heat sink on here. If I need to, I can put a fan through here. And we'll take the RC controller, mount it somewhere like this. A lot of these pins connect here, though some of them connect over to here and here. If I keep all this to one side, leave some real estate here, then I have this big open space here where we can put easily a couple of batteries. These are the two that came with it, but I could probably get at least a third one in here, maybe even a fourth. Haven't decided what voltage I'm going to run this thing at. I don't even know if I'm going to put these in parallel or in series yet. But that's the general plan. So I'm going to get started making holes to mount this down, putting in some standoffs, and then mounting these pieces of hardware to this. Then I can actually start wiring them together at least. The hardware kit also came with a set of these long standoffs. I believe they're supposed to go into these pre-drilled holes here. You can see this lid has some corresponding holes. So that allows you to bolt that down. Might as well install these two. This, I suspect, I'll mount the computer up on top of it. And in fact, I could put more batteries or whatever on top of it. But also the LiDAR and the camera are going to have to go up on here. So my original plan was to use this back plate here. This is just a fiberglass back plate out of an electrical panel. I was going to put this in here. But if you've ever worked with fiberglass, you know, when you start drilling holes or cutting it, you get these little fibers, and they suck. They just get into everything. They're itchy, and they're just not fun. The other problem is, this is also an insulator, so I can't use it as like a grounding back plane. I decided to make just another one out of aluminum. You can actually see it's the same thickness. I don't know what gauge that is. It's probably about 14. It's really thick. But I'll take this, put it on standoffs down in here, and then I can use this as a grounding back plane. It also might, you know, prevent some RF eddy currents or something like that, but basically provides grounding, and I'd much rather work with metal than with fiberglass. So we'll get this in, mounted. Then we can mount stuff to this. Because neither electronics or bearings like little metal flakes, before I start drilling anything in here, these vent holes on these motors, I'm going to cover those up just with some masking tape. To hold this in place, I'm just going to use standoffs, little brass ones. They're just like these, but a lot shorter. The standoffs first I'll mount to here using some Loctite, and that way I can just take this on and off by taking out the upper screws. Alright, that gives us a platform for putting our electronics on. Again, it's going to look something like, I don't even remember now. Maybe something like that. These Lipo batteries have two connectors on them. If you're unfamiliar, this is the one that is typically used for running whatever your load is. This one is connected to each one of the cells in here. You can see it's got 3. And this allows the charger to charge each one individually to the same amount. So these need to be hanging out for charging. These are the ones that you use for actually driving things. The opposite side is this. And I decided that right now I have 2 of these, but if I want to put in more, what I can do is I can just put these all in parallel. They'll run 11.1 volts for all of it. And the easiest way to just allow me to be able to connect any number of these is to actually use these industrial terminals. So basically I'll mount a piece of DIN rail, and then I can run this in and bridge them. Run these in and bridge them. So I'm going to mount one of these somewhere like right here. Alright, next we're going to put in the controller. I'm going to put it that way, all the way to the edge of the board. Make sure we have clearance for a nut here. It's important that you have access to this USB for programming. So, probably right about there. I've got a few things more mounted in. So this is the battery holder mounted. These are mounted. Basically, the battery connectors are going to connect in to here. So we'll have support for up to 3 batteries. The positive will have to run from here, through the fuse, through the e-stop, and then back to the motor controller. We also need to put in a diode because these motors produce charge on braking, and so if you have the e-stop open, we don't want it rolling and producing charge that can't get back to the batteries. Just printing out the holder for that right now. Once that's done, we'll get it mounted. Then we can actually start wiring this up. Here's that bracket printed out. The receiver just snaps in there. So then I can mount that. I don't know, probably somewhere just about like that. I'm also going to hook this up on the bottom side of this switch. This switch actually allows for 2 of these. So I'm going to put this one on the bottom. I'm going to use the top one as a disconnect for everything that's on this upper plate, which we'll be doing much later. Because there's not a lot of space right here to be, tightening these screws on wires, I'm going to pre-wire this with some fly leads, then put it in, then we can put that plate back down on. Now, one interesting thing I noticed is the Robo Claw, which is the motor controller. It says that we should have a resistor across these leads. It's a 1K, so I'm going to put that on. So I'm going to pre-wire this. I'm going to insulate these so that that can't short out. And then have a couple of wire leads coming off of here so we can install it, then we can cut them and strip them to length afterward. Then you end up with something like this. So here's the switch, and there's that 10K, actually 1K resistor between the two that the docs say you need to have. So we'll install this and then work on the fuse. So one side of this switch goes to the positive input on the motor controller. The other side is going to go over to one side of the fuse. Then the other side of the fuse comes over to the positive here. You can see I've opted to just direct solder it here. Got a 10 amp fuse. That seems a little light to me, especially since I've got 15 amp motors, but it's the biggest that came with the kit, so we'll start with these. And then when it fails, we'll move up. Come on now. Okay, so if we follow the... Alright, so let's follow the power. Power's going to come in from the batteries into this side of this terminal block. They're bridged together, so it's all going to come out here, come across into the fuse, through the fuse, out of the fuse, back over to this E-stop. From there, over to the positive on to the motor controller. So that's exactly what we want. The only thing we need now is negative from here, from the batteries, into this block, and then back to the motor controller. So we just need a ground wire from here to here, and that should get power to this motor controller. Alright, moment of truth. We're going to hook up the battery and check power here. We only need to hook up one since we're hooking them up in parallel. Well, we have a power light here, so that's good. Didn't see any smoke come out of the box, also good. 11.6 volts. That's exactly what we were thinking. Should be able to hook up the second one, and I should still get 11 volts. Still 11.6 volts. Okay, looking back at the wiring diagram, we need a diode across here. These motors do regenerative braking, so when it stops, they send power. And if you have this open, so an E-stop pushed, there needs to be some way for power to get back to the battery. So they recommend putting in a diode across here. Got one here. Of course, it's not quite long enough to reach from terminal to terminal, so I'll have to lengthen it, and then I'm going to solder it in as well. Alright, I've got this diode in. Just make sure that the little stripe goes toward the battery, so it's this direction, which goes over and connects to the batteries. Alright, so that's everything for battery wiring. So input. I still have to wire up the motors, the encoders, and the RC receiver, but we'll do that on another video. Thanks for watching.